Okay guys, so in this video I wanted to talk about something called the fundamental counting principle. Now the fundamental counting principle is something that can be applied when thinking about the number of ways to do something. So I'll talk about that in just a second, but just write it out. Okay. Now the fundamental counting principle, like I said, can be applied to find out the number of ways something can be done. So what I mean by that, for example, is let's say you have a path. And at first you can go down two different paths, and then at the end of each path, there are three paths that you can take. Okay. Now, if somebody wanted to know how many different ways, how many different places you could end up, right? Obviously, you could just say 6, right? Because you can count them: 1, 2, 3, 4, 5, 6. But if it got more complicated than that, with bigger numbers, then you would need to use something called the fundamental counting principle. So what you would do is you would take the first number of ways to do something. So there are 2 paths you can take at first, right? And then after that, there are 3 paths you can take for each branch, right? So there are 3. Now, if you multiply those together, you get the number of different ways, number of different places you can end up, right? In other words, the number of different combinations of paths you can take, right? Okay. So that's basically what the fundamental counting principle says, is that if you multiply the numbers, right, the different ways you can do individual things, and you can find out the number of ways you can do all of those things together. So let's say we have something a little bit more complicated than that. Let's say we have a path with let's say there are 500 different paths you can take at first, okay? I won't draw them all out, but just know that there are 500 paths you can take at first, okay? Then, at the end of each of those 500 paths, there are 200 paths. And then at the end of those, all of those paths, there are 100 different paths, okay? How would you find out how many different places you can end up after taking all of those different combinations of paths? Well, you would just have to multiply these 3 numbers together. So 500 times 200 times 100. So gets you 10,000 times 100, which is equal to, 100,000 times 100, which is equal to 10 million. So there are 10 million different ways, different places you can end up after choosing 500 different paths, and then choosing 200 different paths at the end of each one, and then choosing 100 different paths. Okay, let's try a different example. Let's say you want to find out how many different ways you can get dressed in the morning. So let's say you have 5 hats, okay? 4 pairs of shirts, or 4 shirts, right? Let's say 3 pairs of pants, 2 pairs of socks, and 1 pair of shoes. Okay. So how would you find out how many different outfits you can have from that combination of hats, shirts, pants, socks, and shoes? Well, you would take 5, multiply it by 4, multiply that by 3, multiply that by 2, and multiply that by 1, and that would equal, 20, 60, 120. So there are 120 different ways that you could get dressed in the morning on any given day. Okay, so why does this work? Why does the fundamental counting principle work? Well, if we go back to this path example, you can imagine at first you have two different paths to take, and then you have three different paths to take. So basically what you're saying to get the number of, like the total number of ways you can do that, is you're saying for each of those two paths, you have three choices. So you can take path X or Y, for example, and then if you take path X, you have three choices. If you take path Y, you have three choices. In total, that's 6 choices. So you multiply 3 by 2 because there are two different choices at first. Over here, you can imagine there are 500 different paths, and at the end of each path, there are 200 different paths. And then at the end of all of those paths, after you multiply those together, you get a number. At the end of each one of those, there are 100 different choices. So you get a pretty big number, right? So that is how the fundamental. That's why the fundamental counting principle works, sort of. Yeah. So, what are some of the complications that you can run into when you're applying the fundamental counting principle? Well, just make some room here. Let's start with restrictions that you can have. So these are just some of them. But let's say that you need some sort of 4-digit number, okay? You want to find out how many different ways a 4-digit number can be made. How many different 4-digit numbers exist, right? So what you could do is you would find the number of, well, the different digits that can make up each slot. So for example, this last slot here, how many different digits can fit there? Well, we know 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9 can fit in that. All of these different digits can fit here. Same goes for this as well as this. But over here, there is one restriction. 0 cannot be there. So 0 doesn't work. So while these have 10 different digits that you can pick from, right? So 10 different digits. This will only have 9 different digits that you can pick from because it cannot equal, the digit over here cannot be 0. So we would find out that you can have 9,000 different 4-digit numbers. So that's restrictions. What's another complication? Well, let's think. So sometimes, let's go back to our path example. If you had a path example, and there are 2 different ways at first, okay? And then after that, if you take one path, there are going to be 3 different choices. But if you take the other path, there will only be 2 choices. What would you do in that case? Well, what you would have to do is you'd actually have to split them up. So you'd have to say that if you take this path, X, or this path, Y, those are 2 different situations. So if you take path X, then you have 3 different choices. If you take path Y, then you have 2 different choices. And then you would add those together to equal 5. And you would get 5 different locations that you can end up at. So you have to split up the situations because if you take this path, it ends up being 3. If you take this path, it ends up being 2. Okay, so that pretty much concludes those are some of the complications that you might run into. Okay. Yeah, so just to recap, the fundamental counting principle states, this is a 500, states that when you have a situation where you have different choices or different things that can happen over several stages, so this would be one stage, for example, and this would be the second stage, then you just have to multiply the different ways something can happen on each stage together to equal the total number of ways something can happen. So like going down a path. There are 6 different ways in this case because there are 2 ways at first and then 3 ways after it for each path. Then we went over why the fundamental counting principle actually works, and that's because it's basically saying that, or like let's redo that actually. Let's say you have some path. The reason why you'd have to multiply each together is because when you're finding all of these total choices that can happen, you're basically finding, well, if this is 3, there are 3 different ways for each respective path. So each path, basically. So at first, there are 2 different paths, then there are 3 different paths for each choice. So at first, you can take 2 different paths, and then for each path that you take, there are going to be another 3 paths that you can pick from. So there are going to be 3 paths if you take this path, right? And then there are going to be 3 paths if you take this path, and then you add them together. In other words, 2 times 3. And that works for bigger numbers as well. Okay, and then we said, so we ran over some of the complications that you can go over in the fundamental counting principle when applying the fundamental counting principle. Okay, so that pretty much concludes this video. Thank you.